Okay, fun with magnets. So first of all, students, you need what to know what is magnet. Okay, so we will see what is magnet. So what is magnet? The materials to which the object made from iron, nickel, and cobalt get attracted is called as magnet. So basically, magnet is made up of all these things, and these things when get attracted to any other thing, that time this object is called as a magnet. So what is magnet? The material to which the object made from iron, nickel, and cobalt, etc., gets attracted towards the magnet, that is called a property of magnet. So students, you can see here, to the magnet some iron filings are getting attracted towards it. So the iron filings is the thing that is getting attracted towards the magnet. Okay, what is magnet basically made up of? Basically, magnet is the mixture of iron, nickel, and cobalt. It is also called as magnetic material. It is also called as alnico. Alnico means what? Mixture of aluminium, nickel, and cobalt. So basically, magnet is a mixture of aluminium, nickel, and cobalt. Okay. So when the magnet gets attracted to these types of objects, that time they get attracted towards the magnet. So what does the property of magnet is there? Attracting the metals. So iron, nickel, and cobalt, these are all metals. Okay, that gets attracted towards the magnet. So what is magnet? Basically the material to which the object made from, that is iron, nickel, and cobalt, get attracted, those are called as iron. And the property of attraction, what is the property of attraction called? Magnetism. So what is the property of magnet called? Magnetism. So I hope in this slide you have understood what is magnet. So basically magnet is the material to which the object made from, that is iron, nickel, and cobalt, gets attracted, is called as magnet, and the property of attracting the material is called as magnetism. Okay, so moving towards the next slide. What are magnetic materials and non-magnetic materials? So students, here in this picture you can see that many different materials are kept in the bowl, or beaker we can say, and in that dish we can say, and in that dish what happens? There are many different things kept in that dish, and what is done, you can see the magnet is rotated over the object. So what happens? The material which stick to the magnet, those material are called as magnetic materials, and which do not stick to the magnet, they are called as non-magnetic material. So which type of materials get stick to the magnetic material? That is the materials which are made up of iron, cobalt, or nickel. These types of material get attracted towards the magnetic material. So the things which the object or the material which stick to the magnet, those are called as magnetic materials, and which do not stick are called as non-magnetic material. So here you can see that the paper is non-magnetic material as it does not stick to the magnet. Okay, even wood pieces, if you kept in this beaker or bowl you can say, or a dish you can say, so that will also not stick. So the things that do not stick to the magnet, what they are called? They are called as non-magnetic material. Okay, I hope you have understood with these two terms. Let's move towards the forward slide. Now I told you I'm going to show you different types of magnets. So these are the different types of magnet. So the first magnet is known as horseshoe magnet. Okay, it is known as horseshoe magnet. It is U-shaped. Then second is bar-shaped magnet. It is like a bar. Okay, so Kit Kat bar, you must have seen Kit Kat bar. So it is just like a bar. So it is called as a bar magnet. Then we have magnetic needles. Then even we have disc magnets. So these are different types of magnet that we can see. Also you must have seen that each magnet is showing N and S. So what does N and S means? So N means, capital N means north pole or north direction, and S means south pole or south direction. So you can see that each magnet is basically named with the capital letter N and S, where N indicates North Pole and S indicates South Pole. So this is about the different types of magnet. So there are again two different types of magnet, that is natural magnets and artificial magnets. So the magnets which are available from the nature, those are called as natural magnets, and artificial magnets are the magnets which are made uh, uh, from the nature. Whatever material is obtained from the nature, from that the man has made the artificial magnets. So what is the difference between the natural magnet and the artificial magnet, students? The natural magnet is having low magnetic power. Okay, the attraction power of the magnet is low, whereas in artificial magnet the attraction power is more. What are the examples of the natural magnet? That is magnetite and lodestone. And what are the examples of the artificial magnets? There are many different artificial magnets such as bar magnet, disc magnet, horseshoe magnet, ring shaped magnet, cylindrical magnets, etc. Okay, so this is about magnets. So magnets are of two types: natural magnet and artificial magnets. Okay, here are some man-made objects. Now you must have seen that in our house there is a showcase. So doors of the showcase consist of some small magnets. So when you try to close, it automatically get closed. So some magnet is fixed to the doors of the showcase that is available in your house. Even the fridge is also having the same property. The door of the fridge is having the magnet, so it when it closes it gets stuck to each other. Okay, then even the sound systems which are present in our house, such as TV or speakers, so those are also having man-made magnets. That is, they are having the magnets which attract the sound, and it having the power of attracting the sound. Then even in the mobiles also we are having different types of sound absorbing magnet. Okay, it generates all the vibrations of the sound, and it is converted into sound energy, and the sound is heard to you. Okay, then you have a magnetic compass which indicates the direction such as north and south direction. So this magnetic compass is very useful when you are lost in a forest or in a seashore. So what will happen in sea? So what will happen, you don't know the direction where to go, so this compass will tell you the north and south direction, and in that direction you can move. Okay, whenever you are in trouble, so you can take the help of magnetic compass which shows different direction, that is north and south. So here you can see that there are different shapes of magnet also. The shapes of magnets such as ring shaped magnet, bar magnet, cylindrical magnet, disc shaped magnet. Okay, so here are some of the examples of the magnet. Here you can see the different shapes of the magnet. Okay, here you can see the different shapes of the magnet, and here are some of the man-made uh, magnets. Okay, now these are some artificial magnets. Just a second. Just a second, students. Okay, these are some artificial magnets. These are some artificial magnets, that is bar magnet and seashore horse magnet. These are the magnetic needles that is present in the magnetic compass, and here are different shapes. That is, here you can see different magnets which are used according to the requirement to where it is fitted to be fitted. Okay, so these are some of the artificial magnets. So here is magnetic compass. So this is the magnetic compass, how it looks. So here basically it shows north-south direction. Okay, it shows north-south direction. So students, we have studied what is magnet, what is magnetism, what are magnetic materials, what are non-magnetic materials, then natural magnets and man-made magnets. So students, you should also know how the magnets were discovered. So what is the exact story behind how the magnet was discovered? So there was a shepherd named as Magnus. Okay, a shepherd whose name was Magnus from Greece discovered the magnet. Okay, so the magnet was first discovered in Greece. And who discovered? A shepherd. What was his name? His name was Magnus. Okay, what he was doing generally, he was sitting on the rock. And what did he found? That his shoe and the staff remained attached to the rock on which he was sitting. So with a great force he tried to remove his leg from that rock, and in this way the rock was named as magnetite. Okay, and magnetite, as you know, that it is a natural type of magnet. So the shepherd, that is Magnus, who was sitting on the rock, was named as magnetite. Okay, the person who first came to know that something is getting attracted towards his shoes, and he named that rock as magnetite. And as you know that the magnetite is a natural type of magnet. Then again, mariner's compass. So now what is mariner's compass? Mariner's compass was invented from a rock. So this magnetite rock, whatever small pieces were broken down of this rock were known as lodestone. Okay, what does the lodestone means? Leading stone. Okay, lodestone means leading stone. Now these rock pieces of the magnetite were known as lodestone. Now when this lodestone was freely hung, when this lodestone were freely hung means they were tied with a thread, and that thread was attached to the rod, and it was showing the direction of north and south. So the magnet was freely rotating and showing the direction such as north and south. So it was first device uh, uh, to show the direction of north and south. Okay, students, and also it was used for finding out the direction if the person is lost in the forest or in the sea. So with the help of this mariner's compass, the person can find out the direction and he can come towards the correct place. So this is about the mariner's compass. So students, now we know how the magnet was discovered, what is mariner's compass, and how does the magnetic compass works. Okay, so what is magnetic compass? Magnetic compass is nothing but a simple device which is used for finding direction. Okay, what is magnetic compass? It is a simple device for finding direction. And what does it consist? It consists of magnetic needle. You can see a needle here. Okay, here you can see the needle. That needle is nothing but it consists of magnetic needle. And what does the needle do? It freely moves, showing the north and south direction. What does the needle show? It shows the north and south direction. So the directions of north and south may be indicated on the top side of the magnetic compass, or maybe at the downside of the needle. So the names can be replaced on or below the magnetic needle. So basically it is a simple device for finding direction. Okay, I hope you have understood the use of magnetic compass. Then what is mean by magnetic field? Now students, when you keep a magnetic bar in the middle of the paper and you sprinkle some iron filings on the side of the magnet. So what will happen? The magnet will try to attract all the iron filings which are present around it. Okay, what it will do? It will try to attract. So the area which is surrounded by the magnet will start exerting the magnetic force and will attract all the magnetic iron filings with the help of magnetic field that has been produced surrounding the magnet. So magnet क्या करता है यहाँ पे? The magnet is showing some magnetic force exerted from it. So whatever magnetic force are exerted from the magnet tries to attract all the magnet towards itself, and in this way the magnetic field is created around the magnet. That is called as magnetic field. So students, the magnetic lines which are produced on the surrounding of the magnet, those are getting attracted. The iron filings get attracted towards the two poles that are present on the magnet. So magnet, I showed you, magnet is having N and S written on two ends of the two ends. So one end which is noted with N, that is nothing but north pole, and the S is indicating the south pole. Means whatever materials or iron filings are present in the surrounding will be attracted at these two ends only. The iron filings will not get attracted towards the middle end of the magnet. No, it will get attracted towards the north pole or south pole, means at the end of the bar magnet. So it will get attracted at the end of the bar magnet. So now here you can see how does the magnetic fields get produced around the magnetic field. So here you can see how the magnetic fields are produced around the magnetic around the bar magnet. So this blue line, what does it represent? It represents magnetic lines of force. Can you see the magnetic lines of force? No, we can't. But we are assuming that when the magnet is kept in the center, so the blue lines which are representing or which are seen, those are representing magnetic lines of force in the magnetic field. This is how the magnetic field is created surrounding the magnet. Okay, this is how the magnetic field is created around the magnet. Now here you can see very nicely the iron, how the iron filings get attracted towards the north and south pole. So iron filings only get attracted towards the north pole and the south pole. So wherever the filings are sprinkled over the paper, they will the magnetic force will be there, and with the help of magnetic field that will get attracted towards the north or south pole only. So here you can see that the iron filings get attracted towards the north pole and the south pole. Okay, at the ends of the pole only the magnetic iron filings get attracted. And in this slide also we came to know that the magnet is having two different poles, that is north pole and south pole. Okay, so we came to know about north pole and south pole. Now properties of magnet. So in the first slide only what we have seen, the property of magnet. What is the property of magnet? We have seen that the magnet attracts the magnetic materials. So what are magnetic materials? Iron, nickel and cobalt. If the objects are made up of iron, nickel and cobalt, then they are getting attracted towards the magnet. So attraction is one of the property of magnet. So what is the first property of magnet? That is attraction. Okay, then what is the second property of magnet? That when the magnet is hung around with a thread and it is tied to a rod, then it will freely move, showing the north and south direction. North and south direction. North and south direction means the magnet will show you only north and south direction. So when the magnet will come to and rest position, it will show you north and south direction. Okay, Then what is the third property? That the like poles. What does the like poles means? Like poles means same poles. Same poles means what? When north and north pole come together, what will happen? They will repel each other. Repel means um, going away. What does the repulsion means? Going away. When the two magnets come, two sides, that we can say, two poles, we can say, north pole and north pole, when they are brought nearer to each other, they will be thrown away. They will throw away each other. They will not show attraction position. Like poles means same pole, that is north and north, or south. And repulsion means going far away. Okay. And what does the unlike pole means? Unlike pole means different poles, that is north and south pole. Okay, that is north and south pole. And what is the next? That when the unlike poles come together, what we can say? You can see attraction between them. What you can see? You can see attraction between them. So these are the three properties, very easy properties. There are more three properties, but I hope you have very clearly understood first three properties. Let's move towards the next three properties. Okay, now properties of magnet. So what is the fourth property of magnet? The magnetic material acquires magnetism when placed near a magnet. This magnetism is called as induced magnet. So for example, what happens when you are playing with magnet? You try to make the other object magnetize. Okay, so for example, take a magnet, rotate it, say 10 to 12 times on the steel scale, and afterwards what you will see, that the steel scale has become magnetized. Okay, even to the steel scale, iron filings get attracted. But this you can see until the magnetic power is there in the steel. This is a temporary magnetism power in the steel rod. Okay, and this type of magnetism is called as induced magnetism. Okay, so this is for only short time. When the magnetic power is gone off from the steel rod, it will, then the iron filings will not get attracted towards the steel scale. This is the general example I have given you. Then what does the fifth property say? The fifth property says that when the magnet breaks down into pieces, what happens to them? They break into two small pieces. But what is the property of magnet? It shows north pole and south pole. Okay, so even when the magnet gets broken down into pieces, what will happen? Each magnet will become a separate magnet, and again it will have the property of north and south. Okay, again it will have the property of north and south, and it will become an individual magnet. Okay, after breaking it will become an individual magnet, and it will show the same property which the main magnet was showing. Okay, then the sixth point, there is repulsion between the like poles of the magnet. Now what did I say? There is repulsion. Repulsion means going away. So when north pole and north pole is brought together, they will move far away, they will not get attracted. Okay, for example, if your mother is giving you karele ka sabzi and you don't like it, so you will run away from there. Okay, but if she gives you pav bhaji, so you will get attracted towards it and you will come to eat it. Okay, so it is same in the repulsion and attraction. The repulsion means going away and attraction means coming near. Okay, so when two opposite poles, that is north pole and north pole, come together closer to each other, they will repel, they will go away, they will never come together. Okay, and what does the attraction means? Attraction means that when north and south pole comes together, they will happily attract each other. Okay, they will not quarrel with each other, they will happily get attracted. But when the north pole and north pole comes together, they will show the aggressive thing among themselves, and they will move far away. So I hope whatever example I have given you, you have understood the property of the magnet in the same way. Next slide. Here you can see the property of attraction and repulsion. Okay, when repulsion is seen, the magnet will not attract. Here the particles will move in opposite direction. But when there is attraction, they will come together and they will happily get attracted. Okay. In the next slide, induced magnetism. So I told you the example of the steel scale. So when the magnet is rubbed along the steel scale for 10 to 12 times, what happens? The steel scale become magnetized. So there is a temporary magnetism in the steel scale. So this type of magnetism is called as a induced magnetism. Then storage of magnet. So where after use the magnet is supposed to be kept in a safe place in such a way that the property of magnetism is not destroyed. To avoid the property of destroying, so what is used? The keepers, magnet keepers are there. So what are magnet keepers? The magnet keepers are induced magnet in the case. So they are used to protect the magnetic power of the magnet. So what happens? As the time passes, the magnet becomes weaker if we are not using the magnetic keeper to protect the magnet. To protect the to avoid the weakening of the magnet, we are supposed to use the bar magnet that is stored in for using keepers. So students, here you can see to the south pole, north pole is there, and to the north pole, south pole is there. So opposite things get attracted to each other. Okay. So only the keepers are also made in a such a way that they are getting attracted towards the bar magnet. Then what is the electromagnetism? So electromagnetism. So let's take an example of solenoid. What is a solenoid? It is a steel object which is placed inside the coil of wire. What it is? It is a steel object which is placed inside the coil of wire. So what you have to do? You have to pass the direct current through the solenoid. So what will happen? There will be some magnetic lines of force around the solenoid. So you can see the blue lines. What are the blue lines? They are showing the magnetic lines force. So the magnetic field has been get produced around the solenoid. You can see that the magnetic field has been seen around the solenoid. When the current is off, even after the current is off, you can see that the steel rod is found to be magnetized only. So this magnetizing property remains for a temporary period. After that, the magnetism becomes the steel rod becomes demagnetized. Okay, this is how the working of electromagnetism is seen. So what we have taken, basically we have taken a steel object which is having a coil wire inside it, that is called as solenoid. So when current is passed towards the solenoid, what happens? The magnetic lines of force get started flowing around it. And when the current is off, that time also you can see that there is some magnetic power in the steel rod, even if the current is stopped. This is a uh, temporary. This is for just temporary time. After a few minutes, the steel rod will become demagnetized. Okay. Now, if you wrap all your fingers around the solenoid, what you can see? You can see that your fingers are showing the magnetic lines of force and your thumb is showing the north direction. When you hold anything, when you hold a cycle, okay, cycle's handle, when you hold, what happens? You wrap all the fingers around the handle and your thumb is showing one direction. The thumb which is pointing the direction indicates the direction of north, which becomes north pole. Okay. So I hope you have understood this thing also. Then magnetism. So magnetism is maybe temporary or maybe permanent. So what is the temporary magnetism? The temporary magnetism is a magnetism which lasts for short time, and that is for only temporary period. So I told you the example in the solenoid. So till when the current is passing, the magnetic force is there in the solenoid. When the current is stopped, even there is magnetism is seen in the solenoid. But after, when the time passes, after few minutes, you can see that the solenoid becomes demagnetized, or the magnetism power is vanished from it. So this property is called as electromagnet. Okay. So students, what is electromagnet? Electromagnet means the magnetism produced in uh, the electromagnet is a temporary magnetism, and electromagnetism is used in many household purposes. So what are the purposes that are used in household purposes? Such as doorbell, when you swipe your card, then mobile phones. Okay. And then even in the hospitals there are some machines which are having electromagnetism property. Okay, so basically what does the electromagnet means? When the current is put off, the magnetism gets vanished. So such temporary magnet formed due to the electric current is called as electromagnet. So the temporary magnet which is formed due to the electric currents is called as magnetic um, electromagnet. So for example, your doorbell, when current is passed through the doorbell, then only the bell rings, and when you stop ringing it, it stops. After it will ring for temporary period, and after that it will stop ringing. So this shows you the electromagnet property. So magnetism produces electromagnet, and it is called as electromagnetism. And where this electromagnetism is used, it is used in electric doorbells and cranes also. Students, you can see here also there is cranes. So in cranes also you can see electromagnetism. Now, here is the megaclave train. So what is megaclave train? Megaclave train also shows the property of electromagnetism. So you may have doubt that how does the megaclave train shows the property of electromagnetism. So what happens when the train moves? What happens? There is a repulsion between the trail and the rails. So whenever the train moves on the rail, there is a force of friction can be seen, and this force of friction tries to increase the speed of the train, and in this way the train can move from one place to another. Okay, now if there was attraction property in the megaclave trains, then what would happen? The train wouldn't move from one place to another. The train cannot move from one place to another because there is attraction property, so train would be stuck off there only. Due to the repulsion property, the train and the rail, the force of friction is developed between the rails and the trains, which helps the train to take a great speed, and which helps the train to move from one place to another. Okay, then how you can destroy the magnetism power of the magnet? So it is not easy to destroy the magnetism power, but magnetism, you should know that the magnetism power can be destroyed by heating. When you heat any object, that time the magnetism gets destroyed. Even when you throw or knock out or broke an object into pieces, the magnetism power is destroyed. Okay, then also we have studied that when a soft iron bar or a pure iron bar is useful as a magnet keeper. So such bars are called as magnet keepers. So students, here you can see magnet keeper Also here you can see how the magnetism power can be destroyed. It can be destroyed by heating, or by breaking into pieces, or knocking into pieces, or thrown into, or thrown. When you throw in the magnet, immediately it will break into pieces. This is how you can destroy the magnetism power from the magnet. And also students, you know that there is a magnet keeper, which protects the magnet from protect the magnet and all the magnetic properties of the magnet. So this is how we come to an end of our lesson.